lecture and quiz competition organized by SPE Dhaka University chapter. We have arranged a lecture session on improve oil production, EOR tertiary methods. There will be also a quiz competition after the lecture program. Firstly, I want to introduce you today's speaker, Dr. Hussein H. Ahmed. He is a highly qualified professor of petroleum engineering who has over 40 years of petroleum and chemical engineering experience and knowledge in research, training, and consultancy. Currently, Dr. Ahmed is the Director of International Training and Education in a well-established academy. Dr. Hussein H. Ahmed will share his valuable knowledge and experience in the lecture session. Now, I would like to introduce our faculty advisor, Professor Dr. Anwar Hossain Bhuiya of Department of Geology, University of Dhaka. He is the Director of Sylhet Gas Field Limited and also an international consultant geophysicist at BAPEX. Now, I'm giving the floor to our speaker, Dr. Hussein H. Ahmed. Thank you.
This is the title of our course, Tertiary Recovery and Recovering Oil. Why and how do they use it? And sometimes when do they use it? Can we, the question comes sometime, can I use tertiary recovery in the beginning of oil reservoir from the first day without using any secondary recovery? The answer, yes, you can. You can, in certain cases, if you have heavy oil, viscous oil, you can recover it from the formation using the tertiary methods. But sometimes you could leave it till the end of the reservoir. So you have the option. Sometimes I drill a reservoir. The reservoir is very rich with high viscosity oil with API 24 or 22 sometime. We name them as heavy oil. And I know secondary recovery will not work, primary will not work. So I start with tertiary. So yes, so if they ask you in job interview, you apply for a job somewhere, and they ask you, can I use tertiary recovery before using primary or secondary? The answer yes. The condition is if the oil there is immobile, cannot move. So I move it using the tertiary, especially that oils could be very adhesive due to high viscosity or a small API number. Some of the notes I'm going to mention to you, if you have a piece of paper and a pencil, make a note, because some of the information I pass for you will be not found in any books, because it came from my experience. So make a useful of that. The logo you see at the bottom of the slide, that's my company. I'm a director there, and we are very much into education and training. And we are based in Liverpool in England. So my agenda for today, I will talk a little bit about reservoir properties, about the right mechanism, but very much I will focus on tertiary recovery on this point, with some examples and some basic ideas, and also the problems. What are the technical, the operational problems I could face if I use tertiary recovery? I'm going to answer that. Is tertiary recovery an economical methods? Does it worth it or cost me money? I'm going to answer that later on. So remember, I will answer questions on problems of tertiary and also on economics of tertiary. In general, oil exists in the reservoir. We call them sometimes the oil formation, or sometimes we call them the pay zone, sometimes we call it the oil zone. These are having the oil inside it with certain saturation. Of course, you have oil and gas and water together sometime in same formation, and you need to take them out. You need to extract them. So sometime if you just rely on reservoir pressure is not enough. You need to take them out. And one of the way to take them out is using the enhanced oil recovery. So we have primary recovery, and that's from nature. That's from Allah, which will push the oil to the surface. Of course, oil reservoir you can recover luckily by a primary recovery 30%, 40% maximum. But if you have a gas reservoir, as we have in Bangladesh, we have so many gas reservoirs, you can get more than 90% of the gas out of the reservoir using the primary recovery. And that's the difference. Gas is easy to flow, easy to come out. But the gas reservoir, the major challenge for them is the pressure depletion. The pressure depletion rate in gas reservoir is much faster than the depletion rate in oil. I mean pressure depletion rate. But the recovery of gas will be much easier than recovery of oil, due to merely adhesivity, easy to flow, especially if you talk about gas with little condensate. You have to see, in Bangladesh, you have two types of reservoir. You have a reservoir called dry gas, just gas only, and there's a gas with liquid come with it. They call it gas condensate. So you have to produce gas and condensate. Condensate for petroleum engineer, it means the light oil, very light. They call them in chemistry C5 and C6, pentane and hexane. We call them condensate. Usually exists in gas field. So that's the difference as well between gas field and oil field. I have a lecture, not with you, but in next month, I have a workshop on gas reservoir. Once I have it, I will maybe share the link with Anika, and Anika will pass it to you, so you can attend as well. Next month, I will have a 3-hour seminar on gas reservoir, which may be good for you because your country is a gas reservoir country.
Yes, sir.
Then, if the primary is not covering everything, people think about next step is secondary. Step number 2. And in secondary, that could have 2 methods of EOR. If somebody asks you how many methods of EOR we use in secondary recovery, answer to him is only 2 methods. What are they? Water injection and gas injection. Water injection and gas. Remember that. There is nothing else in secondary recovery. Either you do water injection or you do gas injection. Therefore, every chemical injection, thermal injection, CO2, nitrogen, whatever, all of them classified as tertiary recovery. So the number of methods in tertiary recovery is bigger than the numbers of methods in secondary. Secondary is only 2 methods, but in tertiary you have 25 methods. So the tertiary you have big choices, as if you go into a restaurant and you have a menu. They give you a menu before you eat. You can eat whatever, chapati, tandoori chicken, biryani, whatever. You have many choices. That's in tertiary. But in secondary, you have only 2 choices. Either you do gas injection or you do water injection. A primary, it is not you. Primary is from Allah, from nature. Allah gives us a pressure and we produce the oil naturally. So as engineer, as a geologist, you have to think about secondary and about tertiary. Tertiary is more choices, which I will talk about in details later on. But if we understand tertiary, if we understand secondary, it will be easy for us to understand the tertiary because almost same principle. Sometimes also we have something called IOR. So we have EOR and we have IOR. And the IOR sometimes stand for the improve or increase oil recovery. Increase oil recovery. So EOR is enhance. Enhance means support. But IOR increase. And a good example for IOR could be a gas lift, could be electrical submersible pumps, could be infill drillings. So different. So don't be confused. You have a job interview and they want to confuse you and mention EOR and mention IOR. You should know the meaning of both. ER is for enhancing, but IOR to increase the oil production by different ways. So these are the slides. Later on, when I finish, I will email our friend Annika my slides, and she will share the slide with you as well. So in general, as a conclusion, enhanced oil recovery is a well-known technique. So as I said, my presentation about why and how. So if somebody asks you why do we need to do EOR? Why do we need to do, for example, steam injection or polymer injection, or for example, water injection? The answer, because I want to recover more oil from the reservoir and to extend the life of the reservoir. The reservoir, instead of finishing in 20 years, it will remain with me for another 10 years more, so I can increase the life of the reservoir from 20 years up to 30 years using the EOR methods, and sometimes more. It depends on how do you manage it. Secondary mention, tertiary is our topic. So tertiary is usually deal with the remaining of oil in a place. This is the list. This is the menu for tertiary. As you see, this is all tertiary methods. Every single box is a tertiary. If you count them, they are 27 boxes. So we have 27 methods. I can name them tertiary. But I have only 2 methods. I name them secondary. And that's the difference between them. If they discuss with you, so secondary is more focused on building up the pressure of the reservoir, secondary. And increase the pressure of the reservoir is secondary. But tertiary is building on the idea of sweeping oil. Take the oil out of the reservoir. Maybe little maintain for the pressure, but not the main job. The main job for tertiary is to extract the oil out of the formation rocks. So I will cover some of them, and they classify them in 2 terms, thermal and non-thermal. For example, in India, they do thermal. They do have steam injection. In certain area, can't remember the name, but I know they do that anywhere. And other countries such as Oman, they do a lot of thermal. Venezuela, Mexico, north of Kuwait, they do thermal. And many other countries as well, they do thermal, which I will touch on some of them later on with you. And non-thermal, that I can name sometimes the chemicals. So I inject chemical in my reservoir to extract oil. That chemical could be a surfactant. Surfactant is same as washing liquid. The washing liquid or the liquid soap. Sometimes you wash your hand with a soap. Liquid soap, that's a surfactant. Same chemical of shampoo. Exactly same as shampoo. Same as the gel, shower gel. Same principle, same chemistry. Sometimes you are using polymer, and there's different type of polymers. They prepare the aqua polymers, the polymer with water base. Sometimes they use gases such as propane, in general LPG, or sometimes they use CO2, both a gas phase or CO2 as supercritical. Sometimes they use alcohol, ethanol, and methanol. I remember I used to go to Russia and Siberia, give lectures and give consultancy, and they use alcohol there to inject in their reservoir as a solvent, because as you know in chemistry, alcohol is a solvent. And they have big tank filled with alcohol, ethanol. And usually they used to have people guarding that tank because the operator, they want to drink it as a pure alcohol. So they, instead of injecting in the reservoir, they say, I want to drink this. It's a nice, free of charge vodka. But of course, we use it into the reservoir to produce oil. So that's what we name it tertiary. So tertiary is a chemical solvent we inject in our reservoir to increase production by reducing the adhesivity and also give me better mobility of oil inside the reservoir to produce it out later on. So I can use chemicals, gases, or sometimes I use the thermal methods. All come under tertiary. So we have more than 22 methods, I think 27 methods. I counted them here, I put 27 methods. So it's a big menu, and up to you as engineer later on to choose the suitable one. So which one I will choose? The answer, you choose the method suitable for your reservoir. What do you mean? I mean the reservoir in terms of type of rocks, permeability, porosity, the API of the oil viscosity, the gas solubility in oil as well, the temperature of the reservoir, the pressure of the reservoir, the thickness of the pay zone, the depth of the well. All these are important factors you need to consider before deciding on which method I will use. I'm going to repeat. You need to know your reservoir bed thickness, depth of the reservoir, temperature, pressure, oil saturation, oil viscosity, oil API, permeability, porosity, water saturation, gas solubility, salt content, H2S content, and other factors. I'm forgetting them, but these are important factors to consider when you choose a methods for tertiary EOR. You have to understand your reservoir very well before you decide, which we're going to explain later. So remember, this is the menu. It could be this is a smaller menu, this is a shorter menu. This is the major menu. This is a small menu, which I will talk on some of them later on. I will talk about CO2. I will talk about nitrogen. I will talk about steam. I will talk about polymer and surfactant. I will talk a little bit about microbial as well. I cannot talk about every single method in 1.5 hours. I need 6 months to do that because these are big topics. But I choose some sample for you just to learn. If you are in doubt and you need to learn more, please ask and write your question in the chat box. I will answer that later on. So what do I need to know if I want to think about tertiary methods? These are some of the things you need to know. You need to understand your Darcy equation. You need to understand your rock properties, the fluid properties, what's something called mobility ratio, capillary pressures, some chemistry of the crude oil as well as the chemistry we call geochemistry of the rocks. You need to understand something on IPR and flow performance relationship, or OPR, outflow performance relationship. You need to understand something on PVT of the crude oil, such as formation volume factor, solubility, bubble point pressure, and many other factors. So before you go ahead and I say, oh, I want to do solvent injection, I will inject alcohol in my reservoir. You cannot decide like that. No, you have to study reservoir thoroughly. You have to do also reservoir simulation. You are in geology, you have something called Petroleum, don't you? A model called Petroleum for geology. In
Yes.
Petroleum, we have other simulation, such as the black oil or the aspen. And these you need to do good simulation to understand your reservoir before you decide. I just encourage all people, especially young generation, to be as good as possible in IT application in oil and gas industry. You need to if you are a chemical engineer or geologist, so please understand how to run petrol. Petroleum engineer, understand something on black oil and the aspens. If you are a chemical engineer, you do some HYSES processes as well. You need to understand that as well. So now computer is very much important application in oil and gas industry, and try to learn it as well. Learn it. Because now job is very much competitive. After graduation, you find so many people applying for jobs same as you. In order to secure your future, have some skills. And some of these skills could be the IT skills or programming skills, computer skills. Will be a benefit for you. Now, this equation, as I said here, is important to understand it, both for pseudo, for linear flow, radial flow, steady state, semi-steady states. You need to understand how can I play with the terms of my Darcy equation. I put here on the slide only simple example of the radial steady state equation. As you see, the tertiary recovery, mainly the tertiary recovery, the major tackle for it is to play with the viscosity of oil, mu naught. Most of the tertiary methods try to reduce the value of mu naught. Most of them. If mu naught gets smaller, then surely Q naught will be larger. So I increase the production. The other things tertiary can do with, can they play a little bit with PE? They might rise up the pressure a little bit. Maybe they said tertiary can increase reservoir pressure by almost 300 psi as an increment. So if the reservoir pressure is, let us say 5,000, it will be 5,300 psi. So a little increment, but also it is useful to make the oil moving inside the rocks. The other factors could be affected by tertiary recovery is the value of K. K is permeability. So permeability could be also an increase, especially if you have acidizing. So these also are washing. If you wash the permeability from any debris, any participations, you will get better flow. So remember, what does tertiary recovery do for a Darcy equation? The answer, it reduces mu naught, it increases PE or PR, reservoir pressure. It may be number 3, and increase the value of K. Not always, but maybe. So these are 3 factors could be affected, make more production due to tertiary recovery. So that I give you a big flavor or good idea now, because at the time I am worried about, I will start on my tertiary because I give you a reasonable flavor about enhanced recoveries, and I answer some of the questions. Remember, tertiary recovery is quite applicable in this middle pie chart. Heavy oil, very well used, very well known use actually. But can we use it in light oil? Yes, you can, no problem at all. If you have light oil but it's immobile, cannot move due to pressure depletion, then you can use also tertiary recovery. But tertiary recovery is more known in heavy oil. Of course, heavier oil, tar sand is not tertiary. Tar sand is something else, like a chemical extraction, leaching process. But EOR is in heavy oil, especially tertiary methods. And you can achieve a good recovery factor, sometimes up to 90%, if you do it in a proper way. So remember these things in mind. I mentioned the factors, remember? I mentioned all the factors for you regarding the recovery methods. These are in general, but generally I mentioned these things to like to. So very quickly, the one you see here, the slide in front of you, what do you name this one? Shall I name the slide in front of me a tertiary or a secondary? For sure it is a secondary. It is a water injection. I'm injecting the water inside the water aquifer at the bottom of the oil zone, a green and a blue. So I'm injecting water in the blue zone to push the oil up to the surface. This is a secondary. This is a secondary, which is, if you understand the principle of secondary, it will be easy for you to understand the principle of tertiary. So I encourage you to learn more about secondary in order to learn more or understand better. If you learn secondary, you will understand better or easily the tertiary. So don't ignore that. We have something, I can name it injection. Here, I'm injecting the water inside my water aquifer. But if I inject the water inside the pay zone or the oil zone, what do I name it? I name it flooding. Flooding. So in job interview, if he said to you, shall I name it? If I inject chemicals such as solvent or polymer or surfactant or alcohol, ethanol, and I inject it in the oil zone, what do you name it? The correct name, I will call it flooding. If I inject the chemicals inside the oil, water zone or in the gas carb, I name it injection. Therefore, our conclusion is like this. All tertiary recovery are flooding recovery, all of them. All tertiary recovery are flooding. Secondary recovery is injection. So they need also to differentiate between them in this case. These are secondary recovery, so I pass faster a little bit on this slide, and these are water. This is secondary. I pass faster because I'm aware about the time. If I keep talking, I will need more time, and my time is limited because I need to give you a chance also to ask and to discuss other things. Okay, I mentioned to you the word flood and the word injection. I mentioned secondary, tertiary. I mentioned the major factors you need to consider in a reservoir to choose the right methods. We call them selection criteria. Selection criteria. One important factors also to consider in a flooding mainly, is the mobility ratio. What do they mean by that? Mean the speed ratio. Which one is move faster? I am injecting my, for example, the chemical inside the pay zone, inside the oil zone. What do I prefer? Shall I prefer the chemical to move faster than oil, or I want the oil to move faster than the chemicals? The answer, the oil should move faster than the chemicals. The oil move in front of the chemicals to get better recovery. And therefore, the slower movement, slow, S-L-O-W, the slow movement of chemicals I inject, the better for me, the better for recovery. And therefore, make a note of that in your piece of paper. Low mobility ratio, it means high recovery factor. The lower the mobility ratio, the higher the recovery factor. How much lower? I prefer to be less than 1, 0.9, 0.7. That's better. But if I have it equal to 2 or 2.5, no, not better, because sometime now the oil, the chemical will need to move faster and leave the oil behind, which I don't want. And I will show you some slide later on these problems. But sometimes you can argue with me, what shall I do? If I have a case like that, if I have a case where my chemical is naughty chemicals, I need to move far faster. The answer, add some gel materials to your chemicals. Make your chemicals a bit jelly, a bit high viscosity. Make it more viscous. And the surface mixed well before you inject it. That could help and make it slow down. But be careful as well with the chemical you add, because some chemicals can attack the rocks and go damage to the rocks. So you have to balance. You have to do some kind of lab testing. As you know, some of you are geologists, and you know the rocks, some rocks could be interact or interact with the chemical we inject. So we need to make sure the chemical does not react with the rocks I have, such as carbonate rocks or silica rocks or salt rocks, anhydrite, and so on. Tertiary recovery is very much into the issue of sweep efficiency. Sweeping. If you have a dirty, dusty room, and you give a person a brush to sweep the room, and they finish sweeping that room in 10 minutes. But other person, same room, same size, same dust, but he finished it in 20 minutes. Which one you think make better cleaner? The 10 minutes or the 20 minutes? The 20 minutes make better cleaning because it takes time. So the answer now the slower and the longer stay of chemicals inside the formation, the better the sweeping efficiency and the higher the recovery factor. Because sweeping efficiency is part of recovery factor. Recovery, enhance or recovery. Recovery factor made of two elements. The sweep efficiency multiplied by displacement efficiency. Make a note of that. Recovery factor is equal to the sweep efficiency multiplied by displacement efficiency. So the larger the sweeping efficiency, the larger the recovery factor. And therefore, the slower, the better. That's what I mentioned. Remember, I mentioned to you, mobility ratio should be slow. The slower, the better, in order to get more oil out. These are about gas cap. I will not touch them because they are secondary. These are secondary anyway, gas injection. So I move faster a little bit. This slide in front of you, I can name it a tertiary. A gas. Which gas? Maybe CO2. You see this block? Gas. Maybe LPG, propane. And these are the most gas they use. CO2, propane, sometimes they use also natural gas. So the tertiary. And it's a flooding process. And I'm targeting the pay zone. So I have an injection well from one side, and I have producing well from the other side. And the space between the injection and the production, they call them the spacing. You ask me, is it better to make the distance between injection well and the producing well a big distance, for example, 1,000 meters? Or it's better to make it shorter distance, 200 meters? The answer, the shorter the distance, the better. Because the gas would not go everywhere, as if you are just leading it. So the shorter the spacing between injector and producer, the better chance for, I can say, not losing your tertiary solvent or tertiary gas, and to give you better sweeping in this case. Can I use, in the producing well, can I use a production pump, such as road sucker pumps, or maybe I use what they call it ESP, and on the other side I do injection, a tertiary recovery? The answer is yes, you can. Here we have tertiary injection well, and here I have a pump producing well. And nothing wrong with that at all. You can, both of them is applicable. You can also ask me, you say, you have a block here called miscible region. What do you mean? What do you mean by miscible? I meant the gas I inject is totally dissolved in oil. Total miscibility. Is that benefit? Is that a benefit? Is that a positive? Is that advantage? The answer, yes. Why advantage? Because the gas dissolved in oil makes the viscosity small. Reduce the viscosity. If the oil viscosity is small, then it's easy to flow, easy to move. I have no any interfacial tensions or adhesivity or interaction with the rocks. So now I can easily sweep. So remember, miscibility and increase sweeping efficiency. Miscibility and increase sweeping efficiency. Sweeping efficiency increase, then recovery factor increase. Make sense? So make a note of that. So we need to have our chemical injected, it must be miscible. I know we have some time so far, but not bad. We have more than almost 40 minutes. So I will do my best. So that's also important things in tertiary recovery. So remember, in tertiary recovery, remember the term miscibility. I prefer the solvent to be miscible with my oil to reduce viscosity and to make it easy to flow. These are secondary recovery. I will not talk about them. Secondary recovery. A tertiary is miscible. You see this in red letter, miscible. I prefer miscibility if I want to achieve good sweeping efficiency. Miscibility will reduce viscosity, reduce the surface tension between the oil and the rocks, reduce the adhesivity factor, make it easy to sweep the oil. The sweep oil easy, mean recovery factor is high. Does every gas will be miscible in oil? The answer yes, including nitrogen. But when does the gas will be miscible in oil? If the injection pressure of that gas is more than what we call it MMB, minimum miscibility pressure, minimum miscibility pressure. So you can find that value in any guidance book to know what is the MMP. Make the injection pressure more than that MMP, you will have a good miscibility. You can achieve miscibility if you achieve the target of MMP. Capital M, P for Peter, P for ping pong, and that's minimum miscibility pressure. If you make injection pressure more than MMP, you can achieve miscibility. And then what's the advantage? What's the advantage of that? The advantage of that, it will make for me better sweeping efficiency. If I ask you as a geologist, and geologists, you are dealing with permeability and heterogeneity. As a geologist, or as petroleum engineer as well, reservoir engineer, here gas is flowing horizontally from left to right, from injector to producer. So which permeability would be better for this movement of gas? Do you prefer to have a vertical permeability or horizontal permeability? I'm sure you will answer me. Horizontal. Very good. So that's horizontal flow. But if I am injecting this yellow gas in that yellow area, what is I prefer here? Shall I prefer vertical permeability or horizontal permeability?
Vertical.
That's the difference between. And that's what I mean by vertical flow, horizontal flow. And these are important to choose and to study your rocks to know which permeability, which way, which direction it goes. Therefore, I need to make sure when I do my projects of tertiary recovery or secondary recovery, I should have better understanding for my rocks properties. A tertiary project or a secondary project, it costs a lot of money. Sometimes we talk about millions of dollars. Therefore, you have no choice to make mistakes because you lose a lot of money. And that's important. This is the word miscibility and immiscibility. So if somebody asks you, do you prefer to have immiscible flood or miscible? I will tell them I prefer miscible. Why do you prefer miscible? Why do you prefer miscible? Because miscibility will reduce the viscosity of oil, reduce the adhesivity force, and give me better sweeping efficiency. And that's important to keep in mind. These are some of the chemicals I could use. Propane I can use, and carbon dioxide. Nowadays, carbon dioxide became very much famous in EOR. Just before, I think I have last month during Ramadan, I gave a lecture on CO2 EOR. I give it to the SP chapter of UAE, Sharjah and Dubai. So that is important to talk about the carbon dioxide. So if you hear about carbon dioxide, remember to talk about tertiary recovery. And maybe some of you already, especially girls, they pay more attention for environment nowadays, and they say we talk about CCS, carbon capture storage. And the carbon capture storage, CCS, and the principle of it, you can use some of carbon means CO2. You can use CO2 and you inject it inside the reservoir as a tertiary recovery factor to produce more oil and to leave the CO2 inside the reservoir. You can do, if you are a fourth-year petroleum engineering university student, try to make your project, final year projects regarding CCS, and connect CCS connected the EOR. CCS and EOR, nice topic, nice subject, because you mix environment with petroleum. Nowadays, people say to the engineers, you have to think about what they call them E3. The E3 is for environment, and the other E is for energy, and the third E is for economy. Environment, energy, economy. So think about a project for your master degree, MSc degree, under that title, under that vision. You have to have a vision. You have to have a future looking. So think about E3, useful way to think. And you can mix tertiary recovery with E3. So CO2 is a good example of tertiary recovery, a very famous example, a very case study actually. Do we have reservoir around the world that do use CO2 injection? Yes. There are more than 3,120 actually, 3,120 CO2 projects around the world. Can you imagine? 3,120 CO2 enhanced recovery projects around the world. In India, there's something near Mumbai, and I mentioned India because your neighbor. And in UAE, Abu Dhabi, Saudi Arabia, Iran, Canada, North Sea, Aberdeen, and many of them also in USA. They use CO2 flooding. And it's a flooding, we don't do injection. Remember now, tertiary recovery is flooding, not injection. If you want to choose CO2 as a tertiary recovery, think about miscibility. Ask yourself, how can I make CO2 miscible in oil? How can I make? The answer, if you change the CO2 into something called supercritical CO2. Supercritical CO2. Sometimes they write it in certain books as SCCO2, like this. Supercritical. Supercritical CO2. And supercritical mean in CO2 it can almost look like a liquid, but not a liquid 100%, a cloudy things. If you follow me, I think I have put a poster on the LinkedIn recently on CO2. I put some slide like that, and I was asking question. It's better to use liquid CO2 or supercritical? The answer is better to use supercritical CO2. I cannot use liquid CO2 to inject in the reservoir? The answer, because the temperature of the reservoir is usually high and the liquid need a small temperature. To make a CO2 as a liquid, the temperature should be less than 33 degrees centigrade. You cannot get that in a reservoir. Temperature always high. So you can't get supercritical. So supercritical CO2, if you read about it in certain books, is talk about a gas CO2, but in a liquid phase, a cloudy phase. The density sometimes of supercritical is almost 0.7 to 0.8 specific gravity, يعني about 700 kilogram per meter cube. That's the density of supercritical, almost equal to the density of a light oil. So make it very easy to be mixed with oil. Viscosity of supercritical is very small viscosity. Make a note of that. Viscosity of supercritical CO2 is equal to 0.023 centipoise. 0.023 centipoise. Very small viscosity. Density of supercritical is equal to between 600 to 800 kilogram per meter cube, or 0.7 to 0.6 to 0.8 specific gravity. So this is tertiary, a very good example of tertiary. If you want to write a final year projects, or if you want to write an MSc topic, I encourage you to think about CO2 EOR. It's a good topic too, because you will learn chemistry, you will learn thermodynamics, you will learn reservoir properties, you will learn production. So quite useful. So CO2 is very much useful example of tertiary. Of course, you can also, with CO2, you can talk about environment, because you are extracting CO2 out of the atmosphere. So you are reducing also something we call the global warming. Global warming. How much CO2 I can inject in my reservoir? Up to you. But I give you a rule of thumb. They say if you inject 1 ton, 1,000 kilogram of CO2, you will be able to produce 5 barrels of oil. So 1 to 5. Is that good? Very good. Very, very good. So I capture 1,000 meter cube, 1,000 kilogram of CO2 from the atmosphere. I purify it, make it very clean. I inject in the reservoir. It will push to the surface. 1 ton will push 5 barrels of oil, 4 to 5. How many meter cube of CO2 in 1 ton? The answer, 550. So 550 meter cube CO2 is equal to 1 ton, which would be ready to push for you or recover for you 5 barrels of oil. Shall we do it injection? No, I prefer to do it flooding. I flood it inside the oil reservoir. I don't inject the gas of CO2 inside the gas cap. It will reduce the heating value of the gas cap. But do you have a problem with CO2? Yes, any operation you have. The major challenge for CO2 is the corrosion. Corrosion. You are a chemical engineer or you are a chemist. I'm sure you know something about corrosion. Because CO2 is an acid gas. Acid gas. If CO2 mixed with water, it will change into carbonic acid. Carbonic acid may attack the casing or the production tubing, or attack the packer or other sections of the injection well. Therefore, you should be careful by choosing the right materials for your injection well or flooding well. From where I can get CO2? Not from the atmosphere, because not economics, and there's little CO2 in the atmosphere. You can get CO2 from chimney of a refinery or petrochemical plant or power station. Wherever there's combustion, you may have CO2. Capture it, clean it. How much purity I need to have? They said you have to have 99% purity to be injected in the reservoir. So CO2 is a typical example of tertiary recovery. Remember my talk with you about tertiary EOR. A typical example is CO2. CO2 supercritical or CO2 a dry gas, up to you. I prefer supercritical because give you better recovery factor. These are some of the things regarding mobility of CO2 inside the reservoir. You can calculate it actually, how fast the CO2 will move inside the rock. I have here gas CO2, and the gas CO2 is moving. Here it is, CO2. I'm flooding it. It's moved from the injection well to the producing well. Usually, the maximum distance between injector and the producer no more than 400 meters. That's maximum. I prefer 200 meters. As a consultant, if you consult me, I tell you make it 200 meters between injector and the producer for a CO2 to get better response, better recovery, less problems. That CO2 will dissolve in oil, which is called miscibility, and that will help in reduce the viscosity of oil, which make it easy to flow. So it's a flooding CO2. And that CO2, the speed of movement, you can calculate it using this equation. You see if the speed of CO2 in feet per day. Depending on density of oil, density of CO2, the dip angle, and of course, especially in horizontal flow here. Or you can say, you can argue about the sine alpha. If you say sine alpha is 180, it will be a problem. But generally, I go for that factor mobility ratio, and I use UC. UC with my calculation, if you give some data, you will have it about 0.34 feet per day. The speed of CO2 moving in the rocks in a typical reservoir is equal to 0.34 feet per day. In other words, every 3 days, CO2 will move only 1 foot. And that's a very good way of speeding, of sweeping, because I don't want to have mobility ratio higher than 1. So if you are in job interview and they ask you, give me typical example of tertiary recovery, remember CO2 supercritical. I don't have enough CO2. I don't have plenty CO2. So can I reduce the amount and make it more effective? And the answer is yes. Use something called WAG, water alternate gas. Remember, WAG is another example of tertiary recovery. You're mixing flooding of reservoir with gas and water. Gas and water. So first you inject the gas, CO2, maybe for 3 months or 4 months. Then after that, switch off the compressor of CO2 and start the water injection pump for another 3 to 4 months. And by this, you sweep more oil. So in the beginning, CO2 is dissolving, miscible with oil, and pushing the oil, and then the water will give more power to sweep the remaining oil behind, as you see in this slide. So it's more effective. Again, job interview. And they said to you, we don't have enough CO2, expensive to buy it. Can you just suggest for me another way to make it cheaper? Tell them use CO2 WAG. CO2 WAG, it means inject CO2 first and then follow that with amount of water. That will help to give you better sweeping efficiency because of the miscibility and also because of water will push everything out. Water, some of the water will dissolve in CO2, or CO2 dissolve in water, give me acidic water, and the acidic water also good, because acidic water will increase the permeability of the reservoir. If the permeability of the reservoir increase, then production increase. Remember that equation? So CO2 will reduce viscosity from one side in the miscibility, and also it will increase the K permeability, and the water injection will increase the pressure of the reservoir. So you have 3 gains. You win 3 wins. K is larger, pressure is larger, viscosity is smaller, and you achieve better. So remember, WAG CO2 is a good example of an optimal recommendation for tertiary recovery. And these many examples on it. I know the time is really hitting me very, very bad. Another example of tertiary recovery is thermal recovery. And then after that, I will stop. And in thermal recovery, the aim of it, the major aim of it, is to reduce the viscosity of the crude oil, to make it easy to move, easy to be swept. So thermal recovery is very much targeting viscosity in Darcy equation. And how can I increase the temperature of the reservoir? Either by injecting steam, or injecting hot water, or use a fire inside the reservoir. So injecting a steam, as you see in the slide here, I prepare the steam in the surface, and I have something called a steam injector, steam generator. So I take the water, boil it, put it under high pressure, give you a very hot steam, high pressure and high temperature steam. How much the temperature of the steam? It's about 560 degrees centigrade. Very hot steam. What's the pressure of it? The pressure could be up to 35 bars, high pressure. And I inject it inside the reservoir, inside the oil zone. This technique they call cyclic or half and puff. So first in half and puff, this is stage number 1. I prepare my steam and I inject it inside the reservoir. How many days? Maybe I keep injecting maybe for 7 days, a full week. I start Saturday and I stop Saturday. When I stop, I shut the well, close it, and I go home. Then I leave the steam inside the well, captured there, for maybe 4 days or 5 days. We call it soaking time, soaking time. Then I come after the soaking time and I open the choke at the wellhead and the oil will come produce. I produce for a full month, a month of production. So I do lose maybe 10 days, but I produce for 30 days, huff and puff. So the cycles in steam, it has 3 stages in one cycle. Stage number 1, steam injection, they call the huff. Stage number 2, soaking time. Stage number 3, production time, they call puff. And I repeat it again, I repeat again, until I get as much as oil I can get. The major factor here, the steam, heating up the oil, reduce viscosity, make it easy to flow. This kind of tertiary recovery is suitable for heavy oil, viscosity more than 200 centipoise. For shallow wells, not very deep wells, could be 1,500 to 2,000 feet depth. And low production, you produce about 200 barrels per day from the well, which is not bad because now you can make money. 1 barrel is $100. So if you produce 200 barrels, multiply by $200, $100 by 200, so you make $20,000 every day, which is not bad at all. You can make good money. And if you have so many wells like that, you can produce up to 1 million barrels. A good example of this is used in Oman. They have certain oil fields producing this way. And Oman producing about 1 million barrels per day of oil. Venezuela as well. Mexico as well. Some oil fields in Kuwait, they use also cyclic. Maybe some of them later on in north of Iraq, we have some heavy reservoirs such as Najma and Ayara. They could use the same technique. So the huff and puff is very useful and important. I have 15 minutes or less for your question and answer, but I will talk about, I talked about CO2 example, steam is another example, and there are so many examples. I have no time to cover them all. I wish to cover them all, but no time. I do encourage you in steam flooding to understand more about heat transfer, radiation, convection, conduction. Understand more about heat transfer in rocks, sandstone, limestone, specific heat capacity. So you have to have a good understanding for the mechanical heat flow. The in-situ combustion, I have seen that in certain countries, they put the injection well as a burning well. So they set a fire on the well, injection well. They connect it to an air compressor. We have igniter, and we have oil, and we ignite the oil inside. So we have a very hot, burning oil inside the wellbore, pushing it to the producing well. It has many disadvantages, such as formation damage, whatever, but this is suitable for a high viscosity crude oil, almost like an asphalt. But do they use it? Yes, they use it. I know, I have seen personally some of them in Oman. Interesting subject. So you have to think about more about steam and so on. I will use only one example of chemical, and then I stop. So the chemical flooding, tertiary recovery, they use sometimes surfactant. Surfactant is the soap, washing liquid. So same as any washing liquid, you mix it with water. Every bottle of water, you put almost 1 kilogram of surfactant liquid, mix it very well, and inject it in the injection well. So now you're injecting a soapy water. And that soapy water start washing the ropes as if you are washing your hand. If you have eat a heavy meal, a fatty meal, so how do you remove the fat from your hand? You will tell me, I wash my hand with a soap. Same idea. How can I move the fatty oil from the rocks, high viscosity oil from the rocks? The answer, I will inject that in a soapy water, and that soapy water will dissolve the oil and give me a good, less adhesivity and a good mobility and a reduced viscosity. And then because of the pressure of water injection, the oil will move with the soap together to the producing well. And in the separator, I will separate the soap from the crude oil. How much recovery factor here? I can tell you no less than 75%. You can recover almost 75% of the oil in a place. Very high recovery factor. Expensive? Depend on, yes. You have to buy a good amount of soap. Sometimes the soap could be expensive because it's a special soap anyway, because it needs to withstand a high temperature reservoir and also withstand a salty water, formation salt. So it could be expensive. How much soap I need? They said 1 kilogram of soap can sweep 2 barrels of oil, which is not bad. 1 kilogram of soap can sweep 1 barrel of oil. So that's a good example of chemical flooding. There's so many other examples about polymer and other things which I have no time to talk about. Maybe in the future, I give you more time for these workshops to make it useful for you. But now, unfortunately, my time is limited. These are some of economics as well in terms of expenses. For example, polymer costs about $30 per half a kilo, surfactant $1.20 half a kilo, and depend on oil price as well. So you need to think, these are all data, but all I need to tell you that tertiary recovery sometimes could be expensive. Therefore, you have to choose it if the oil price in the market is encouraged. So don't forget economy. Don't forget feasibility of the project. And again, I encourage some of you to do some research on economy of EOR methods. Nowadays, there is something called microbial. You can use the microbes in a certain culture to produce for you some kind of biosurfactant or bioacids, and then inject that biosurfactant inside the reservoir. I have done a research on that, and it was successful. I did the research in 2019, and I got reasonable recovery factor. I use a biosurfactant. I will move faster now. Unfortunately, the nanotechnology is a good subject of topic. Nano in enhanced recovery is something also need to be looked into. The nanoparticles as well, need to think about them. Again, this is a good research title for building MSc, nanotechnology and enhanced recovery. Nano is a tertiary recovery. Microbial is a tertiary recovery. This is a good area for research anyway. If you need my help, you can email me. I will give you my email in a minute. Nitrogen also could be useful. I'm moving very fast now because of the time. These are some of the problems. Fingering is a problem. Remember I mentioned mobility ratio. The mobility ratio, the smaller the better. So M here 2.4 and the M here is 17. So 17, a high mobility ratio, I have an early breakthrough, a poor recovery. But better recovery if M is small one. If you make M equal to 1, would be wonderful. Here's some of the problems you could face. This economy as well. So economic wise, as a tertiary methods, I can look into CO2 as recommended process. Reasonably, not very expensive. This is economy. CO2 in the heart of the business. Surfactant expensive. Thermal reasonable. Polymer also could be expensive, depend on the type. Microbial is under research. Maybe in Bangladesh, think about microbial because you have so many organic materials. You can make out of its fermentation process, and you can produce bio surfactant or bio ethanol. So it could be used as a tertiary. I'm sure in Bangladesh you produce nowadays, this is season I think of mango. And now mango season in Bangladesh. You have so beautiful mangoes, don't you? So you can use some, so you can use some of the mango juice for fermentation and you produce biosurfactant or bioethanol, biosolvent, which could be used for tertiary. So in this case, I think I come to the end of my slides. Thank you.
For your phenomenal lecture and presentation. I hope everybody has enjoyed the session and learned a lot. Now it's time for the question and answer segment. You can just unmute the microphone and ask the question or type it in the chat box. I think we already have got a lot of questions in the chat.
I can read first comment from Gloria. Gloria saying, if I have heterogeneity of reservoir. Heterogeneity is not good. It is an enemy. It is a failure reason for tertiary recovery. So be careful you have no heterogeneity in the reservoir before you start a tertiary recovery methods. Heterogeneity means that you have a changing in the value of permeability. Due to fractures, or could you due to some shell content, and these could be cause a problem in that case. I think somebody is also same lady Gloria raising her hand. You want to ask? Unmute yourself and ask.
Thank you
Alaikum
so
salam.
Alaikum salam wa rahmatullahi wa barakatuh. Thank you for a nice webinar and presentation as well. So I added heterogeneity when you just mentioned how to choose the city-pole criteria for the reservoir for tertiary enhancement or enhanced oil recovery. That's one of my just contributed when you mentioned about I think 12 agents choose this suitable for reservoir type. Thank you so much for your presentation, Prof. Hussein.
Thank you. And thank you for your comments. Your comment is also a correct comment. Thank you.
So thank you very much again for answering the questions. Hope everybody got their answers. Now I would like to give the stage to our president to have a little word with us.
First of all, thank you so much, Hussein Ahmed sir, for your insightful presentation. We have learned a lot, and as a fourth-year student, we get a better understanding about petroleum production. Also, I would like to thank our faculty advisor, Dr. Anwar Bhuiya sir, for supporting us from the beginning. And last but not least, I would like to thank all of the committee members. They really worked very hard to make this program successful. Now I would like to give floor to our faculty advisor, Anwar Bhuiya sir, to speak something for us.
Thank you very much for a nice presentation, Dr. Ahmed Hussein. It was a timely presentation for the enhanced oil recovery. And I also like to thank the organizer of this student chapter. If I want to say something about the petroleum system in Bangladesh, you know, we have approximately 30 gas fields. And unfortunately, we didn't have any oil field in Bangladesh. We had a oil field, but it stopped after a small amount of recovery. And from the gas fields, we used to have the condensates, 11 barrel or 10 to 11 barrel per million cubic feet gas production. So in that case, we can use this technology, but we always use the secondary or the primary recovery measures to enhance gas recovery. Naturally, our gas are mostly dry, and the condensate usually have the high API value. So we are lucky in that case, but our students will be working worldwide in the future. So it will be very nice presentation. So most of the students attended today is coming from the 4th year, 3rd year students. And we used to give lecture or offer courses of the enhanced oil recovery or this type of courses in the master's program. So this will be a very nice preparation for the next year. And then once again, I want to thank Dr. Ahmed Hussein for his excellent presentation. And I got your advice. Then we should not only make them study, but we always try to help them, and then we will continue to help them to be prepared for the future job in different countries or different oil fields, gas fields worldwide. This will be very good. And then in this way, we are actually increasing our cooperation, collaboration in the international arena. I hope this type of arrangement, seminar, symposium, presentation will help our students a lot. Thank you very much once again. Have a very nice time. Thank you. So if Dr.
Thank you, my friend Anwar, for your comments. As I said to you, your students are as good as any student around the world. So they are as good as any European or non-European student. They are clever. They are two hardworking students, I'm sure. And maybe some of them one day finish working in Middle East or Far East. You never know. Could be in Malaysia, could be in Indonesia, could be in the Gulf area. So they need to be equipped with knowledge as well as skills and abilities. So, and I'm more than happy to liaise with our friend Anika and with you as well to deliver more workshops regarding skills development. I have a nice workshop, three days workshop, about the title of it, what shall I do after graduation? What shall I do after graduation? So that's full of advices. How can you sell your CV to the employees or to the employers? And how can you do well in a job interview, locally and internationally? So maybe I'll arrange something like that which could be useful for everybody in the university, not only petroleum, but any other person. They need to know, what shall I do after graduation? How can I write my attractive CV? And if I go for a job interview, what shall I do? How can I answer? How can I convince the panel that I am the right candidate? So maybe we'll arrange something like that in near future. So Eid Mubarak to everybody. Thank you very much. Wish you good luck.